Building reliable AWS Lambda functions with idempotency using AWS Powertools and TypeScript. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. In cloud computing, primarily within distributed systems, ensuring that operations are idempotent is crucial. This is particularly important for AWS Lambda functions, where repeated invocations can occur due to retries or other factors. In this podcast, we'll explore the concept of idempotency, its significance, and how to implement it using AWS Powertools and TypeScript in an AWS Lambda function. We'll also dive into a practical scenario of booking appointments at a doctor's surgery to illustrate the necessity of idempotency. Introduction to idempotency and its importance. What is idempotency? Idempotency is the property of certain operations that produce the same result even if performed multiple times. In simpler terms, no matter how often an idempotent operation is executed, the outcome remains the same. This concept is crucial in distributed systems, where network issues, timeouts, or retries can process the same request multiple times. Why is idempotency important? In distributed systems, ensuring idempotency prevents unintended side effects such as duplicate records, incorrect data updates, or unnecessary charges. With idempotency, repeated operations can lead to consistency and potential data corruption. Overview of AWS Lambda and Powertools. Introduction to AWS Lambda. AWS Lambda is a serverless computing service that allows you to run code without provisioning or managing servers. It automatically scales your application by running code in response to events. However, because Lambda functions can be triggered multiple times by the same event, idempotency becomes a critical consideration. The role of AWS Powertools. AWS Powertools is a suite of utilities designed to enhance the functionality of Lambda functions. It includes utilities for logging, metrics, tracing, and idempotency. By leveraging AWS Powertools, developers can implement best practices in their Lambda functions with minimal effort. Scenario: booking appointments at a doctor's surgery. To understand the importance of idempotency, let's consider a scenario where you're building a serverless application for booking appointments at a doctor's surgery. Imagine a situation where a user clicks the book appointment button multiple times due to a slow network. Without idempotency, this could result in numerous bookings for the same appointment slot, leading to chaos. By implementing idempotency, you ensure that only one appointment is booked, regardless of how often the user submits the request. Implementing idempotency with AWS Powertools. Step-by-step guide to implementing idempotency using AWS Powertools for Lambda. Setting up your project. Start by setting up a new TypeScript project for your Lambda function. Install the necessary AWS SDK and AWS Powertools packages. npm install at AWS SDK/client DynamoDB AWS Lambda Powertools idempotency. Configuring AWS Powertools. AWS Powertools provides an idempotency utility that simplifies implementing idempotency in Lambda functions. You can configure it to store idempotency records in DynamoDB. Code implementation. Setting up DynamoDB for idempotency records. You'll need to create a DynamoDB table that will store idempotency records. Here's a simple example of how to set it up. Import DynamoDB client, create table command, from at AWS SDK/client DynamoDB. Const client equals new DynamoD client region, US East 1. Const create table equals async, equals greater than. Const command equals new create table command. Table name, idempotency table. Key schema. Attribute name, idempotency key, key type, hash, attribute definitions. Attribute name, idempotency key, attribute type, S, provisioned throughput. Read capacity units, 5. Write capacity units, 5. Semicolon, try. Const result equals await client.send command. Console.log table created successfully, result. Catch, error. Console.error error creating table, error. Semicolon, create table. Creating the Lambda handler with idempotency. Now, integrate the idempotency check into your Lambda function using AWS Powertools. Import, idempotency, from AWS Lambda Powertools idempotency. Interface appointment request. User id, string. Appointment date, string. Const handler equals async, event, appointment request equals greater than. Const idempotency equals new idempotency. Table name, idempotency table. Client, new DynamoDB client region, AWS 1 : return idempotency.handle event, async, equals greater than / your logic to book an appointment. Return, message, appointment booked successfully. Semicolon. Export, handler. Handling errors gracefully. Effective error handling is crucial for maintaining idempotency. Use try-catch blocks to manage errors and ensure the Lambda function's output remains consistent even when mistakes occur. Try. Const result equals await handler event. Return result. Catch, error. Console.error processing request, error. Return, message, failed to process request, error. Testing the implementation. Testing the idempotent Lambda function with Postman and expected outcomes. To test the idempotency of your Lambda function, you can use Postman or any other HTTP client to simulate multiple requests. Ensure that even with repeated requests, the function only processes the booking once and returns a consistent response. curl x post https:// your API endpoint.amazonoz.com/prod/book appointment. H content type, application/JSON. D user ID, 12345, appointment date, September 1, 2024. Check DynamoDB to confirm that only one record is created and subsequent requests return the same response without creating new records. Conclusion and further learning. Idempotency is critical in building reliable and robust distributed systems, especially in environments like AWS Lambda. Using AWS Powertools with TypeScript, you can simplify the implementation of idempotency and ensure your serverless applications are resilient to repeated operations. For further exploration, consider diving deeper into advanced idempotency strategies, exploring more features of AWS Powertools, or integrating this approach with other AWS services, such as SQS or SNS, for more complex workflows. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.